We're talking about question sets based on this table.
Yes.
Okay. Cool.
So we have the 5 rules.
Mm-hmm.
I guess I'll just look at this here
Damn.
since I don't have all these. Okay, so we want to calculate the first of S. So we look at the first thing in the set of S. That's A.
Right.
Okay.
So we apply rule 3, right? So the first thing we do, right, when we want to calculate the first of S, we only look at the production rule that has S on the left-hand side. So that's the first thing we do. We pre-filter out all those other production rules. We said we only look at rules where S is on the left-hand side.
Okay.
Because there can be multiple. Right?
So then you look at the first element in S, and that happens to be A.
Right? Exactly. You look
Okay.
at the leftmost symbol here.
So then what happens next, right then? Like what do you think? Like.
So we apply this rule, right?
Okay.
So I'm applying this rule. Here is first of A.
Okay.
Right? And here's first of S. So I'm adding the first of A minus epsilon to the first of S.
So
then I ask
first of
myself,
A.
what's the first of A?
Okay. And it could be either C or little a, big C or little a.
Nope.
No.
So this is one of the nice things. So you're trying to look ahead and pre-compute it in your head. Don't want to do that at all because you're making it too complicated. All you want to do is look at this table and say, what's the first of A, the last value for first of A that I have?
Empty set.
Empty set. So that's what I do. I take the empty set, I subtract epsilon from it, which is still the empty set, and I add that to the first of S, which is the empty set.
So why did we put the extra space there? That was just
For the formatting
just
thing.
to show you.
No, it's just a problem.
Oh,
It's not-
okay.
It's not anything.
Doesn't mean anything.
No.
Okay. Okay. So we always just look at that column.
Exactly.
Every
yes.
time. So
That's
when do we look at these over here then?
So now when we calculate the first of A, which of these rules on the left-hand side do we look at?
First of A, well then we look at A, and then see that big C.
Which of these rules?
Oh, A goes to CD.
Just this rule, right?
Yeah.
So maybe I'll do that next time. It's like we could block out all these other rules,
Okay.
and we only focus on those rules. And actually, there's 2 rules here, right? The or means that there's 2 rules.
Yes.
So we have to choose. We look at them one at a time, but apply all the rules to each. Doesn't matter which
Okay.
order we do them in, but we have to do both.
Okay.
So we first take A goes to big A, big D, right? So I apply rule. I want to apply rule 3,
Yes.
right? So which is the leftmost symbol of this rule?
Big C.
Big C, exactly.
Okay.
So I take first set of big C minus epsilon. What's the first set of big C?
Empty set.
Empty set. Boom.
Ah. Okay.
Empty set to A. Did that. I ask myself, do any of the other rules apply? Do I go on to add the first of D to the first of A?
Well, it was empty, so it could still be rule. Which one's rule 4 again? Yeah, let's check real quick. So if epsilon is the first of B0, and epsilon, so it could still be rule 4. So rule 4 potentially.
Potentially. It could be, right? But when do we know that rule 4 applies?
Goes first B and first B by. So if there's some non-empty set, the after.
Not empty. What does it say explicitly?
So
Yeah,
basically,
does it contain epsilon, right? Is epsilon in the first of a symbol, the leftmost symbol,
okay.
right? So is epsilon in the first of big C?
Yes.
Is it? What's in that set? How many elements are there in that set?
Okay, well, it's not epsilon, it's empty.
It's an empty set. There's
So
nothing
epsilon
in it.
isn't empty? What's epsilon representing then?
Epsilon represents an empty string.
Empty
A
string.
string of length 0. But epsilon
Okay.
is a thing, right? So if you have a
Okay.
set with nothing in it, right?
So
if I
empty
ask
set
you
versus empty string.
exactly, so if I ask you what's the cardinality of this set, the empty set, how many elements are there in it?
0.
Right. If I put epsilon in there and I say what's the cardinality of the set containing epsilon?
1.
1.
Okay.
Exactly.
Gotcha. So
Perfect. So that's why I don't apply rule 4
because
now,
it doesn't contain
at
epsilon.
this point. Exactly. Yes.
Okay.
And I look at the first of C here. I say it's empty set. Epsilon's not in there. Bang. I'm done.
Okay.
I know rule 4 and rule 5 don't apply, right? Because there has to be epsilon in these symbols to apply those in the first set of those symbols to apply these rules.
Okay.
Then I go to the next rule. Big A goes to little a, big A,
Okay.
right?
So in that same square, you're now looking at big C and little a.
But I just did C and D. So I
Yeah.
just
So now
did this.
you've looked at that. Now you're gonna look over at the other side of the.
Exactly.
of it. Okay.
Yes. So I look at the other side and I say, okay, let's apply rule 3. What's the leftmost symbol?
A. Little a.
right? So what's the first set of little a? It's not in my table, so where do I look?
So you have to look at one of the rules. That's rule 1.
Boom. Yeah, rule 1, right? So then I
Okay.
take that, I say, okay, this returns, the set containing a, and then
Gotcha.
I subtract epsilon from it. So what's the set containing a minus the set
Epsilon.
containing epsilon?
A.
It's a, the set containing a, right? Exactly. So I add that into the first of a.
Okay.
And then I ask again. I can ask again, right? Rule 4. Does rule 4 apply?
There's no epsilon. So
Exactly.
no.
There's no epsilon in the first set of little a, right? So I don't
Okay.
go on. And so I'm done. So now I say, hey, the first of a is little a.
Gotcha. Okay. Makes sense.
So then what's the first of b here? Yeah. No, I don't know. I don't know what you want.
Yeah, I'm gonna, as long as you're willing.
First of C, first of D.
Mm.
How could you, why did you add the epsilon?
Okay, perfect. Yeah, we'll step through that because that's actually pretty complicated. Okay, so here we have, so first of b, right?
Just goes to B.
Just as for little b, right? So we apply rule 3 and then rule 1, right?
Okay.
Perfect. So now we want to do first of c, and this is where it kind of gets tricky, right? So we take this rule, little c, big C, right? We apply rule 3.
Okay.
So we say, hey, what's the first set of little c? We apply rule 1. We say it's clearly the set containing little c.
Yes.
We subtract epsilon from it, then we add it. So we know the first of c contains little c,
Yes.
right? Then we look at the other rule, right? So the other rule says, okay, c goes to epsilon, right? So I apply rule 3.
Epsilon minus epsilon.
Epsilon minus epsilon is what?
Nothing. Empty set.
Empty set, yes, exactly. It's the empty set. So we add the empty set to the first of c, right? Which doesn't change anything, right? So
Okay.
c is still the set containing c at this point. But then we ask, okay, does rule 4 apply?
Yes.
What was our condition for rule 4?
The first element had to be epsilon.
Right, there has to be an epsilon in the first of the first symbol. But that rule says if there is, then you can add the next symbol to the first of a, in this case c. But is there a symbol after this epsilon?
No.
No, so we can't apply rule 4, right? There's nothing afterwards.
So therefore, you just take that epsilon. That was the first element.
Then I ask if rule 5 applies,
Okay.
right? I still haven't checked that. So does rule 5 apply? So how do I check rule 5?
They have to all be epsilon.
All be epsilon. So are all the symbols in this rule on the right-hand side of this rule, are all the symbols, is there epsilon in the first set of all these symbols?
Yes.
Yes. Then I add epsilon into...
So rule 5 is the one that's being applied.
Exactly, yes. And that's an incredibly pedantic point because when you look at this, you can easily do, yeah, it's C and little c and epsilon, right? Like
So if
you
you're
just look at this
programming
and do
it, you
that.
have to have the rules to do it.
Exactly, yes.
Yeah.
So that's how you know your rules are working correctly because you don't have to special. There's nothing special about epsilon in there. It just applies all of these rules.
Okay.
Does that make sense? Yeah, so I think the way to maybe do it, I don't get a good. I don't know if this is going to copy paste in here.
A little bit. Yeah. Fuzzy.
Crazy fuzzy. Because I want to have these. Maybe I can do something like.
Screenshot.
No, I'll do side by side or something like that. What do you mean you won't go smaller? What? Programs are stupid. Okay. So we have the rule. Right, we have, let's say just the stupidest simple case, right? S goes to epsilon.
Okay.
Right? Just the empty string.
Yes.
Like, what's the first of S? Right, this is what we want to calculate.
First of S. Okay.
So first, right? I know S is a non-terminal, right? So I have to first apply rule 3, right? So rule 3
Well,
says, hey,
how do you know it's a non-terminal if it's going to epsilon?
because non-terminals are only on the left and it's uppercase.
Ah.
Exactly, yeah.
Okay.
So all of the non-terminals will be
So
here.
you always have to apply rule 3, even if it goes to something that's a terminal, essentially.
Yes, exactly. That's the thing.
That didn't make sense to me because if I saw it going to a terminal, I figured you just applied.
Yes, you can do that because you're human and you can take shortcuts.
Okay.
But the computer, right, just algorithmically
Has to apply it.
apply the rules. Yeah.
Okay.
That way, it doesn't matter if it's whatever. You can just calculate it. So we say, okay, first of S, right? So I say, okay, take rule 3 says take the leftmost symbol, add the first of B minus epsilon to the first of A, right? So if I like kind of draw this out, so applying rule 3 means that I'm going to say first of S is equal to, I'm going to shorten this to just F, first of S union with first of epsilon, right, minus the set containing epsilon,
Okay.
right?
Yeah.
So this is just straight application of this, just substituting in. Here I have S is A, right, in this example, and here I have this B is epsilon, right? So just straight substitution, right? So then I can say, okay, how do I know the first set of S?
First set of S.
Yeah, so this is the first set of S, right? So I say
Okay.
it's adding it, right? So what did I calculate as the first set of S?
Epsilon.
What do we do first? What's the very first thing we do in that table?
We look at the empty string, or empty set.
Empty set,
Yes.
exactly, yes, right? So I look and see, okay, the previous value of S is the empty set,
So you put
set.
empty set there. Okay.
So I put empty set here, exactly.
Okay.
Then I say, how do I calculate the first set of epsilon?
Rule 2.
Rule 2, right? Rule 2 applies.
First set of epsilon. Okay.
Which is just the empty set.
Right? Yeah, then I do this, right? So I take this here. You're going to be deleted. I don't know how to delete you. But guess I could put that. Okay, so what's a set containing epsilon minus the set containing epsilon?
Empty set.
Empty set. And the union of two empty sets?
Is empty set.
Empty set, right? So I just applied rule 3, right,
Okay.
to this. And didn't change anything. Rule 3 did not change anything. Right?
Okay.
So then I say, okay, I did that. Can I apply rule 4 to this?
Yes. Because that's that contained the empty set.
Right? So rule 4 says, hey, if I have a B0, right, the leftmost symbol, if there's an epsilon in its first set,
Check the next
then
one.
add the symbol after it to the first of S.
There isn't any symbol after it.
There's nothing here.
I mean,
It's empty.
The rule applies, but it does
The
nothing.
rule apply, but it's nothing, right?
Right.
There's nothing here. You can't add anything after it if there's not anything there. Right?
Isn't that rule 5?
No, rule 4.
Rule
Right, we're
4?
just talking
Rule
about
5
rule
is,
4.
and Rule 5 also applies because you went through all your sets and the
Right.
last set contains
So we
the
check
empty
rule
set.
4 first, and then we
Okay.
check rule 5. We say, does rule 5 apply? So what's the K here? If we were to like simplify this down to where we're at now. What's this K here?
0.
0.
0, right? So we say, okay, that's 0. So is the first of B, is epsilon in, that should be epsilon in first of B0. Interesting. Never noticed that. Okay, is epsilon in the first of B0?
Yes.
Yes.
Yeah,
then you add
so
it
that
back.
checks. Is it through all the BKs? So BK is 0, right?
Correct.
So we just check that. So then we add epsilon to the first of A. But what's A in this case?
S.
S, right? So by applying rule 5, right? Rule 5 says, hey, if we just look at that, right? It says if epsilon exists in the first of epsilon, right? Then, I'm going to do this as a then first of S is equal to the first of S union the set containing epsilon, right?
Okay.
So then I've already calculated this, right? This is the set containing epsilon, right?
Okay.
So is epsilon exist? Is it a member of the set containing epsilon?
Yes.
Yeah. Boom. Checks passed. So this means I do this. So what's the first set of S?
Empty set.
Empty set, yeah? Right, so I do empty set union with epsilon. So I say, okay, in this step I calculated the first set of S is the set containing epsilon.
And so rule 4 failed because there wasn't a second character that wasn't a non-epsilon value.
Yes.
Would it better, or not a better way, a different way of saying Rule 5 is just if you've made it through all of your rules and your last first set still contains an epsilon, then you just add that epsilon back in.
Yes.
Okay.
That's the way I think about
It's
it.
a simpler way of saying it. Because seeing that rule looks confusing.
Yes.
for lack of a better term.
Yeah, so then after one application of this step, right?
Okay.
So when you actually, program this, and I mentioned this in class, you don't actually program it recursively. Would you, see all your rules, set aside sets for them to create, initialize them to the empty set, and then just do passes on them?
Yep.
Similar to how we did it in class. Okay.
That's exactly how you do it.
Interesting.
And all you got to do is write. So you got to write sets somehow. You have to have some way to determine to create a set. You need these operations here. You need union, and you need subtraction.
Would you be able to
That's it.
do this recursively? Or would you have to come up with
You
a
would
sixth
special
rule
case
to
the
handle?
case if you. But I honestly I don't think so. You'd have to manually detect when you're in a cycle, right? Because if you have A goes to A, yeah. Well, that's easy to check because you're doing A. But you could have A goes to B, B goes to C, C goes to D, D goes to A.
We could just
Right.
keep track of what rules
Yeah.
you're applying on, and if you
We
run into a
detect a cycle.
conflict.
Yeah.
On the programming side, we have to define all these rules and then just pass them through it, right?
Yes.
Can you maybe post some examples, like supplemental examples that we can verify and sort of go over ourselves on our own time?
Yeah, there's other examples in the slides.
Is there other than
This
the
is
one?
what the homework is.
If you go for it.
Okay.
And the homework is
okay.
more examples.
Gotcha.
I have other examples I can give out, but they're
Okay. But there's more on the slides. I can
Yeah.
go through those too.
For the midterm, is there going to be similar questions to the
Mhm. Yep.
I'm gonna have to go over your video
Okay.
because
Cool.
I didn't understand.
All right. Well, that's why we have the videos. Good. Yeah, and you can. I'm recording this too, so this should be helpful.
Yeah, it is very helpful.
I think.
Yeah, actually, that's what I was gonna ask you if you're gonna put this in.
I try. You have a question, Sarah?
Yes. So for the definition of first set, I'm still kind of hung up on it.
Sure.
With the first rule, it kind of bothers me just because it's derived from X, but we don't derive anything from the terminals. Or is a parse tree different from the actual deriving? Because when I was doing the deriving here for the homework, it's I see how it, from here to here,
Right.
when you're deriving, I mean, this is the first symbol when it's derived from A in a way.
I guess
I
I mean
just don't
deriving more in the tree sense. I think of it
But
as
nothing comes out of the tree.
right. So I think about if you start at a root, right?
Yeah.
So the idea is if I start with a terminal A, right, or some non-terminal,
Yes.
right, I know that by applying all possible of these rules, I'm going to create a crazy tree,
Yes.
right? So it's saying of all possible things that I can create, if I wrote out all the strings there that they could create, what's that first character that's in all of these, or the first terminal?
Yes.
So the same logic to me applies here is, okay, I could write out all possible.
But nothing comes out of the
What's the string
non-terminal.
here? That's the thing is what's what are all possible strings that are derived from A?
There are plenty of things that are derived from the non-terminal A, but
So what are all the strings that are derived from this?
nothing. Nothing
Nothing?
comes from it. That's my intuition that nothing comes from it.
Isn't this equivalent to this string?
But that's already the string. It's
just looking at trees, I think, right? So if you had, I don't know, S and you have A and you have B, you have A and you have B like this, right? So if I look at any of these in isolation, right? I understand what you're saying. So if I look at A, right, and I just have the rule, let's say we have the rule A, B, right? A goes to little a, B goes to B, right?
Yeah.
So if I have big A, right? So I say, okay, all possible strings trees that start with A as a root,
Yes.
right? What are all possible strings? What are they? Right?
So just little A,
It's
yeah.
just A, right? This is the only possible string,
Yeah.
right? By the same logic, if I just look here
Okay.
and I say, okay, if I use this as the root, right? Okay, it's the root. It's also a leaf. It has no
Yeah.
children, but it still
What are the
represents the
strings
string
that-
A.
okay.
Exactly. So that's what I
Yeah,
think of as
that-
derived
okay,
from, like
that makes
all
more
possible
sense.
things.
But like the derived just implies that like something is coming from it, and I know like nothing comes from the leaf, so
Yes.
that was just difficult terminology to.
Yes.
Wrap my
Derived,
mind
I guess, is I can understand it's confusing because we use it in
Yeah,
different
okay.
places. Okay.
Thank you.
Gotta leave.